Okay, 5C. Region R is the base of a solid. Keyword. So that's a volume. R is now the base of a solid. So, let me draw some stuff here. For this solid, each cross section, every slice, keywords, go slow, perpendicular to the x-axis is a square. So that means we stack squares on this thing. And the squares, that purple line is the edge of a square. So I'm drawing several different squares. Every purple line is the edge of a square. If you pulled out the square and looked at it, that would be the purple line. And then being a square, the other two dimensions would be the same. We draw them in different colors so that we illustrate that the square is coming out at you, and the purple is what's touching the base. This little tiny square here would have a side like that, and then coming out would be something like this. Three-dimensionally, it's hard to draw, but something like so. You've got slices coming out of the board. Something like that. The slices come out of the board like that. Okay. So we focus again on the fact that to find volume, we're always going to find the flat area of a slice. So we need to find that flat area. Well, this dimension in purple is simply the y at the top subtract the y at the bottom. So that's just g subtract f. And that works for any of the squares. So that's the dimension of one side of the square. You multiply that by itself, you get the area of the flat section of the square. You multiply by dx, you get the volume of a slice. That will find the volume of one slice at whatever x you pick. We want to do that for all the x's, so that's it. We're done. It's it right, but do not evaluate. So let's just check our points here. Part C, that's it. 1 point for the integrand, 1 point for the correct limits. There is no constant in this case, so 2 points total. Be very careful when you grade. It's got to have exactly what you see there.